Good morning, all. So we shall continue our lecture. In previous lecture, we discussed about process planning with the examples. Our process planning sheet. We have discussed how and what are the process sequence we need to do. For this particular example, also we discussed like what are the process is needed, what are the consideration we should give, and what kind of sequence it should be performed, including material, including tolerancing level, and how to prepare, what are the information available in the process planning sheet we discussed. So in that continuation, so process planning can be done in two way, but in traditional way, only one way, like a process planner does the job. So process planner then he or she should be having a experience, and manually they will be doing this process planning. Experience in the sense they will be having all the exposure about the industry, all the details, all the knowledge about the industry based on their service. They gained all the data. So with that availability of their skill set, they prepare the process plan. And they also have the capability of managing the situation. So this is how it has been done. So it's based on experience and also performed manually. But it depends, since it's a process planner individual, so it differ from person to person. Difference of opinion might be there from one person to another person, so he make another one person make a different process plan comparing with another person, so consistency won't be there between process planner, because individual judgment and experience can provide different thing. Then in current era, modern industries, they are not getting people like in the past with enough expertise. Lack of skills are there nowadays, so people are not modern industry are facing difficult, because modern industry mostly like industries are mostly depends on experienced people. So the transition period is now, because industry 4.0, and we are discussing about that. In many country implement industry 4.0. So in India we are in transition period, and most likely we are crossing like a 50% crossed now. But still industries are feeling like they feel like a lack of skill set in the labor force. So that's why they feel difficulties in using traditional processing. So comparing with the past, they are trying to implement computer manufacturing, computer assisted process planning, or computer process planning, like that. They are trying to implement. So this computer integrated manufacturing are not new. In the 80s itself it came in, and process of evolving. It is industry 4.0. Even people have started discussing about in industry 5.0. So where computer supporting us to prepare a process plan. Okay. So it can also called as a computer assisted part programming. I don't think so. We can restrict the process plan with part programming, but it can be where machine also support to write some statements, and it also translate information as a machine code, which can be understood by the machine control unit to process. And also they use some ABT language. APT means automatically programmed to languages they use. With that information, they prepare some kind of process plan. So what is the role for each and every one there? What is the programmer job? Means individuals will be defining the geometry of that work piece, what they want to do, and what sequence of operation it should do, and what kind of tool path it should travel. But computer will perform like a translation. What are the information programmers giving? It will be translating that for the benefit of machine control unit, and it also calculates some arithmetic, like how much x coordinate, y coordinate should go, like arithmetic calculation will do. And also it will also automatically plan the cutter offset calculation, and perform some post processing, like generate some codes for toolpath. Okay, so even though programmers are giving inputs, that inputs will be translated by the computer for to make machine control unit to understand. Like the codes will be calculation will be done in the computer processor. So APT means what? It has automatic programmed tool language. It has a four statements defining for definition of geometry, for motion statement, for post processor statement, and auxiliary statement. So definition of geometry in the sense what? The geometry definition section list of appropriate statement used to define the geometry of the component. So geometry in the sense a kind of profile of the component. Like the profile in the sense we have to start with a point. It should with point to point we can able to connect to line and planes and circle etc. So profile of that geometry which we are going to make in the machine like a product profile we can able to create using geometrical components, so that can be defined in that ABT language also. Again, we can able to set the statements or define the statement for motion control, like tool, how the tool should go, like go from one place to another place, or go delta, DLT, means go delta. It's kind of go delta in the sense tool position only, but relative position. Go to in the sense absolute coordinate system. Go delta means relative position, and go to is the absolute, and offset and tool left, go upwards, tool down. That is what the short form of statement. Motion statements are available in that program. With that, those commands can be given as inputs. It depends on the geometry. Okay, then post processing statement, because once we set that geometry and also we are having the motion statement, it's not at all, no, it's not sufficient. We need to provide some auxiliary commands or additional commands. The additional command like what is the feed rate, when the how about the coolant, whether to turn on the coolant or not, what kind of cutter, means we need to provide dimensions or characteristics of the cutter, and tool or tolerance, TOLER means tolerance value we need to give. So how much tolerance we need. Cutter in the sense what kind of tool, what is the diameter of the tool, which material of the tool. Coolant means on and off. Feed rate means how much feed needed for that particular operation. Feed 500 means 500 millimeter per minute kind of thing. So that inputs we need to give as a post process statement. Then auxiliary statement. This section correctly mentioned these statements include miscellaneous command functions, or we can able to name the program, or adding some kind of understanding, like the program should give some detailed information. So someone X or Y reading the program, they should know what this command. Maybe they may be giving like a statement which is not necessarily processed in the machine control unit, but as a programmer we can able to give some input for our understanding. But it won't be processed. Maybe like okay, these codes are for doing this turning operation, or this is for this codes for doing thread cutting operation, like that. That kind of auxiliary commands also we can give. So those all the things can be done through this APT statements. So what are the advantages of having computer assisted uh, part programming only I can able to say. So process planning is one support. Okay. So it rationalize and standardize. The CAP leads to more logical and consistent process plan compared with the traditional process planning. Why in the sense? In the traditional process planning depends on individuals, right? So their skill set, experience, knowledge, and but competitive process planning will give logical and standard process plan comparing with the traditional one, and we can get comparatively we can able to get increased productivity for the process planner. From process planner we can extract more productivity than the traditional way, and we could be able to prepare the process plan little quicker than the traditional way, so reduced lead time. Then legibility over manual written rule sheet. So computer program means the legibility will be there. Then other tools also we can. The CAP can include other programs like cost estimating, like applications, or making work standards, or NC part program if you want to create. We can able to club together. The cooperation, like collaborative work is possible, and it save lots of time for making a long part program, and it reduces the procedure, minimize the error, and it create automatic code for toolpath or for machining. And it also we can able to do some kind of background analysis so that we can able to obtain optimal path, and also it can be visualized in graphical way. Okay, so and also it can reduces demand on the skilled planner. Like we need for computer programming, we need everything, but number of skilled laborers can be minimized. Okay, so as I said, lead time or process planning time can be reduced, and also it reduces the manufacturing cost, and we can able to create the consistent process planning throughout. Okay, because we have a stored memory of process plan. So if we are preparing something new for our industry, it can refer our existing one. We can able to prepare that consistent process plan, and also most accurate process plan can be produced. So these are simple advantages of computer assisted process planning. So various approaches are there under the computer aided process planning. One is variant or retrieval type of process planning, and generative type of process planning, and automatic system, automatic way of creating the process plan. So we'll go with one by one. First type, variant or retrieval type of computer-aided process planning. This computer-aided process planning, that is the variant type, is basically with the help of group technology and part coding and the classification system. So basically, it uses group technology and part classification and coding system only for this one. A standard process plan is stored in computer files. Actually, in variant or retrieval, from the word we can able to understand that retrieval means retrieving something from the existing system. So standard process plan will be stored in our computer file based on our past experience. We prepare what all the things we have prepared, we can able to store that in our computer system for future for each and every component. So for example, we have a hundred number of components or parts being manufactured in our plant. For each and every component, we should have some code number, part code number. So for that particular part, for the particular part, we have a process plan. So that will be stored in the computer with the name of the part code. So if we want, if we similarly 100 process plan, if we stored, suddenly if we are receiving some new component, so we have to do that. We have to, again, new component means we have to provide some code. So that code definitely going to match along with the existing component, not necessarily exactly if it is matching exactly, in the sense what similar process, the same process plan we can able to retrieve and use it. If not, some variation in the part geometry comparing with the existing one, but similarities are there, right? So if there are some similarities means, so we can choose which is closer to the new component. That process plan we can be able to take and do some modification according to the new part features or geometry. Then we can able to produce the manufacturing. We can able to execute the manufacturing or production. So that is what about variant type or retrieval. This is in short I have given. Okay. So basically, standard plans are available, stored. If if we are receiving any new product, then we need to retrieve similar, similar, we need to identify similar process plan in our system, and if it is not exactly same, retrieve the similar one and modify according to our need, and then we can able to execute. So this is what general view for your retrieval system. So this right side is showing the clear idea or flow for retrieval type computer process planning. If the file does not contain a standard process for the given code number, assume, as I said, new product is coming inside our plant as a new order. We need to label that product as a new with the code number. So if that file does not exist, so what they can do, the user may search file for a similar code, not same code. If it is not there, similar code. So by searching the similar code, we can take it or retrieve it. Then we can do the edit on the existing process plan. If at all nothing is there, only we have to go for starting from the scratch. Okay. Then if nothing is there, we need to do that new, and we should store that in the database so that in future we can able to do. So this is mainly for computer aided process planning of retrieval time. So here it is clearly says new part design comes. We need to derive GT, group technology code number for part, means we need to give some code for the new part. Then we need to do search for part family for GT code number which we assigned. So if we search in them, it will go to the part family file, and there should be a database will be there. Selecting coding system from the part family, and if we have then prepare the standard process plan for the part family, then standard process plan file will be there, and it will be sent to the retrieval standard process plan. Okay. If there is a small changes needed in the process plan because the geometry of the product what we have for new order is little different, in the sense we are going to do some editing, right? We are going to do some editing on the existing plan. If nothing is done, we are going to do the new process plan from the scratch. Once we done, again we are going to store that in our standard process plan file. Then in future purpose we can able to retrieve. So once we done that, process planner do the format, or it can able to collaborate with other, then he will be preparing the process sheet. So this is the flow. Clear? I think you guys are clear that retrieval system is using the existing standard process plan. If that how we are going to search, in the sense through the code number of the each part. If similar code is not, if same code is not there, we need to find the similar code, then retrieve that process plan, edit according to the new component. Then again we need to store it to the stand in the database. Okay. If for the new code we don't have any similar code or same code, what we need to do, we need to start from the scratch, prepare the process plan, again store it in the database for the future purpose. So this is what the retrieval system all about. So final step in the process planner format is the formatter may call other application program like a miscellaneous code, or cutter operations, or cutter conditions, or standard time calculation, or cost estimation, and can be done by the formatter, or maybe process plan. So, so the pictorial view, there is a new drawing or geometrical view. It's coming. We are giving some code. That code will be searched in the family. Like a family means like a database will be searched if under standard process plan will be there. So from the search, we can able to get retrieve kind of standard process plan. According to our need, we need to do some editing. Once we done the editing, it's over. Similar, if nothing is there, then we need to do the coding, prepare put it under some part family. Then standard plan needs to be stored in the database. So this is how. So two process also possible in the retrieval type computer process planning. So in order to give a little more idea about, because as I said, retrieval system mainly works under group technology, part classification, and coding system. What is coding system? So coding system example is, this is the coding system. Here there is a number 0, 1, 2, 3, 4, 5. The unique, there is a number. So each number represents some kind of shapes. For example, what is the primary shape of the product? What is the secondary shape? What is the auxiliary shape? Or what is the initial form of the piece? Like that, there is a coding system. For example, primary shape is length by diameter ratio is less than or equal to 0.05. We need to code like 0. If the primary shape length by diameter, length and diameter of that workpiece is between 0.05 to 3, in the sense it should be labeled as a 1. Length by diameter ratio greater than 3 means labeled as 2. So similarly, if the primary shape is a flat, then we have to label like a 5. Then secondary shape, there is no secondary shape is available. With screw thread is available, with functional grooves are available, rotational cross section is there, rectangular cross section is there. That is the secondary shape. It has its own code. Axillary shape. What are the axillary shape? What is the initial form of the thing? So based on this, we have to send some kind of code. So with this code, we have to store. Means it's labeling the part. Okay. Then coding operation mode like 01 means saw operation, lathe machine, grinding. Like various operations are there. Operation codes are there. For operation plan, we need to prepare the operation code. With this operation codes will be useful for retrieving it. So this is one of the group technology coding system example. OPITS is the film researcher or professor who created this classification system. See, there are digit number 1 to 9 is there under based on his principle. Digit 1 to 9 is there. So digit 1 is part class, digit 2 is main shape, digit 3 is rotational machining, digit 4 is plain surface machine. Digit 5 means additional holes teeth are forming. Then supplementary codes are there, 6, 7, 8, 9. So in digit 1, 0 to 9 is there. Under digit 1, first digit, 0 to 9 is there. What is 0 to 9 in the sense? Under 0 to 5, you have a rotational component, and from 6 to 9, you have a non-rotational component. So in the rotational component, how the component being subdivided depends on the length by diameter ratio. If the length by diameter ratio is less than 0.5, then it is labeled like a 1. Length by diameter ratio is greater than 3, it is labeled as 2. Similarly, if digit 2 represent element shape, main shape, it represents the main shape, and digit 3 represents the rotational shape, digit 4 represents the plane surface machining, like each and everything is thing. Then supplementary codes like 6, 7, 8, 9. 6 is representing about the dimension, 7 is representing material, 8 is representing about the original shape of the raw material, and what like accuracy we need, that is also represented in digit number 9. So this is example for OPIT's coding system. There are 5 digit like what are the 5 digit? Digit 1, 2, 3, 4, 5 for this component is given like code number 15100. What is 15100? What is 1? The first digit. What is 1? Digit 1 in that they given like a 1. So this is 1. 1 in the sense the length by diameter ratio are between 0.5 to 3. Let us check. So length by diameter ratio is 1.5. Where is the length? Here is the length 1.5. What is the diameter? Maximum diameter is 1. So length is 1.5 divided by 1 is 1.5 is the length by diameter ratio. So length by diameter ratio 1.5 means it is between 0.5 to 3. So it is labeled as 1. Then 5 is external shape. Both ends stepped with the screw threads on one end. Okay. So both ends are stepped with screw thread on the one end. Digit number 2 represented with the 5. So digit number 2 represented with the 5. Okay. Similarly, internal shape. What is the internal shape? Third one is the internal shape. Third is the internal shape. For internal shape also it is given like one part containing a through hole. If a part containing a through hole, it should be labeled as 1. Then plane surface machining, nothing is there because it's a rotational component, nothing is there, it is given 0. Is there any auxiliary holes or gear tooth available? Nothing is that, then it is given 0. Similar. So depends on the shape of the component, we have to give the coding. So this is the part code. So this code will be stored in the database. So as I said, if we are receiving same kind of shape for the new order, directly we can retrieve this code and related process plan we can able to perform. Or if we are receiving similar, not same, similar shape, we can able to retrieve this, but according to the need we have to edit that, then we can able to edit the process plan also. Okay, for example, instead of length by diameter ratio 1.5, if length by diameter ratio is more than 3, then it should be, if length by diameter is more than 3, in the sense what, maybe we have to use 2. So then code will be 25100. Other things are same means 25100. So this kind of simple modification we can able to do instead starting from the scratch. If we don't have anything, we have to prepare in this way and store it. Okay. So this is basic example for coding and classification system under grouping technology. So similar kind of product will be grouped as a individual part families. Okay. So we have to remember that. Then another example for farm code, length by diameter ratio for 1, 2, 3, 4, 5 length by diameter. What is the external shape? What is the internal shape? Is there any surface machining is required? And is there any additional holes? Yeah, see, they have given number 2 because additional holes are there here. Auxiliary holes are there. And some external slots needs to be performed. So surface machining also needed. So that's why the number is 12132. So it depends on each and every geometry of the product. We need to provide some coding with the OPIDS coding system. So under part coding and classification, we have n number of classification system. So this is one example. Okay. So we are not going to discuss in detail about other coding and classification system because if the subject is different, like under computer aided manufacturing subject, we can able to see in detail about how we our group technology subject we can able to see what kind of part coding and classification system in detail. Okay. So with this, I like to wind up this lecture. In this lecture, we have discussed about fundamentals about computer aided process planning, and traditional process planning. What is the advantage of traditional process planning, or what is the limitation of the process planning? We have discussed comparing with that how the computer aided process planning advantages, what is meant by automatically programmed tool, what are all the statements available under that ABT we have discussed, and some benefits of computer assisted computer aided process planning, and different types of computer process planning available, variant type, generative type, and automatic type. In this lecture, we have discussed about variant type alone. So in our next video, in our next lecture, we will be discussing about generative systems and automatic process planning system. Okay, thank you.